Section 4.2, Trigonometric Functions. SOHCAHTOA, SOHCAHTOA, is something that is used in trig, and it basically is a keyword to help you remember. S stands for sine, and it's opposite over hypotenuse. C stands for cosine, and it's adjacent over hypotenuse. T stands for tangent, and it's opposite over adjacent. So when you have a right triangle, the hypotenuse is always directly across the right angle, and depending upon which angle of reference you have is how you label the other sides. If this angle here, as denoted by theta, this side that's touching the angle is the adjacent side, and this side here is opposite side. If I still make the same triangle in the same pattern, the hypotenuse is still directly across. However, if my reference angle is now up here, the other side touching the angle becomes the adjacent side, and this now becomes the opposite side. So if I'm going to be labeling my sine, cosine, tangent, first thing I want to do is make sure I label my sides appropriate. This is adjacent and this is opposite. So if I make the list of my trig functions, sine, cosine, tangent, cosecant, secant, cotangent. So with the word SOHCAHTOA, the sine is the opposite over hypotenuse. And again, these are going to be referenced to lengths of sides. You'll have some numbers. Cosine is going to be adjacent over hypotenuse. Tangent is opposite side over adjacent side. The cosecant, secant, and cotangent are just the reverses of sine, cosine, and tangent. So since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite side. So now let's put some numbers in that. Let's say I have this ordered pair 3, 4. If I make my axes and I count over 3 and up 4, I can draw my right triangle right within this range. So the length of side on the x-axis is 3. The length of side on the y, or the distance, is 4. What I need to calculate is my hypotenuse side. And for that, I'm going to use Pythagorean theorem. C squared is equal to a squared plus b squared. If I rework this, I can say a squared is equal to c squared minus b squared, or I can say b squared is equal to c squared minus a squared. But I'm going to be looking for the hypotenuse. So c is going to be equal to the square root of a squared plus b squared. So I go 3 squared plus 4 squared. That's going to be 9 plus 16 square root, which is the square root of 25, which is 5. So my hypotenuse length is 5. First thing I want to do, my reference angle is right here along with the x-axis. I'm going to label my sides. This is my adjacent side, this is my opposite side, and this is my hypotenuse. So now that I have all 3 sides labeled, all 3 sides have numbers, I can go ahead and make my list. Sine, cosine, tangent, cosecant, secant, and cotangent. So sine is opposite over hypotenuse, So the opposite side is a 4, and the adjacent side is 3. Opposite over hypotenuse. So that's a 5. Cosine is adjacent over hypotenuse, so that's 3 over 5. And tangent is opposite over adjacent, that's 4 over 3. My cosecant, secant, and cotangent, all I need to do is take the reciprocal of each one, and I have the ratios of all of my trig functions. Notice that the value of sine is positive, cosine is positive, and tangent is also positive. I'm going to use that information to build my relationships in my quadrants. For each quadrant, I'm going to put sine, cosine, tangent. So in quadrant 1, which that one we just did, all three of them, sine, cosine, and tangent, were positive values. Let's try one that's in a different quadrant. Quadrant 2 will have a negative x and a positive y. Let's give that one a try. Actually, let's just use the same numbers, only make them negative. That way we can just run through it quick. So if my ordered pair is minus 3, 4, that's going to put me over here in quadrant 2. So minus 3, 4. There's my angle, or triangle right here. There's theta. This is my adjacent side. This is my opposite side. This is my hypotenuse. So this is minus 3, 4 on the opposite. And again, Pythagorean theorem will yield the same number, because when I square the 3, it still comes up to a 9. So this is the square root of 25, which is 5. So now when I make my list, sine, cosine, tangent, cosecant, secant, cotangent, sine is opposite over hypotenuse, so 4 over 5. Cosine is adjacent over hypotenuse, so it's minus 3 over 5. Tangent is opposite over adjacent, so it's 4 over negative 3. And for the other trig functions, cosecant is going to be 5 over 4. Secant is minus 5 over 3, and cotangent is minus 3 over 4. So in quadrant 2, sine is positive, cosine is negative, and tangent is negative. Sine is positive, cosine is negative, tangent is negative. Let's try one in quadrant 3. In quadrant 3, the ordered pair would be minus, minus. So minus 3, minus 4 puts me right about here. So this is minus 3, minus 4 on the y, and here's my hypotenuse. And again, when I calculate my hypotenuse, the negatives are going to square out. So 9 plus 16, this still comes out to a 5, square root of 25. This is a 5. So my list of my trig functions, sine, cosine, tangent, cosecant, secant, cotangent. Sine is opposite over hypotenuse. Let's label my sides. This is adjacent, this is opposite. So opposite over hypotenuse is minus 4 over 5. Cosine is adjacent over hypotenuse, minus 3 over 5. Tangent is opposite over adjacent, so minus 4 over minus 3, which is a positive 4 over 3. Flipping them around, cosecant is minus 5 over 4, secant is minus 5 over 3, and cotangent is a positive 3 over 4. So in this case, sine is negative, cosine is negative, and tangent is positive. There is an acronym for this as well. All students take calculus. The A stands for first quadrant. All of them are positive. This is the second quadrant. Sine is positive. This is the third quadrant. Tangent is positive. And this is the fourth quadrant. Cosine is positive. So without having to figure out the last one, I know cosine will be positive in that quadrant. So we're going to be using that quite a bit. Not necessarily in this section, but we will be using it in another section. Let's try one more example. Let's say we have the ordered pair square root of 2 and minus square root of 5. First thing I want to know is where this is. And again, this is just going to be an estimate. So when I'm doing this out, square root of 2 is approximately 1.4, and square root of 5 is approximately 2.2, so a negative 2.2. So I'm pretty much, let me make this bigger so that we won't be so much over there. Let me just make the axes bigger. So let's say I am approximately here, third quadrant or fourth quadrant. There's my angle. This is hypotenuse, this is adjacent, and this is opposite side. Again, it's opposite because this is theta over here. This is the opposite side. The only two sides that touch the angle are the adjacent and the hypotenuse, and if it's not the hypotenuse, it's got to be the adjacent side. The hypotenuse is always across from the right angle. So here, this is the square root of 2. This is the minus the square root of 5. So what I need to do is figure out the hypotenuse on this. And even though I'm not crazy about the numbers, it's still done the same way. So this is going to be square root of 2 squared plus the negative square root of 5 squared. So the square root of 2 squared is 2. And when you square square root of 5 and the negative, you get a 5. So this is going to be the square root of 7. So the hypotenuse is the square root of 7. So now I make my list: sine, cosine, tangent, cosecant, secant, cotangent, and of course SOHCAHTOA as a reference. Sine is opposite over hypotenuse, so minus the square root of 5 over the square root of 7. Cosine is adjacent over hypotenuse, so the square root of 2 over the square root of 7. Tangent is opposite over adjacent, so it's minus the square root of 5 over the square root of 2. Now, I cannot leave a square root in the denominator, so I need to rationalize these. And again, to rationalize, you just multiply by whatever the denominator is, because the square root times the square root is that number. So square root of 7 times square root of 7 is square root of 49, which is 7. And this would be minus the square root of 35. Again, rationalizing this, square root of 7, square root of 7, so I get square root of 14 over 7. You cannot reduce that because the 7 is not in the square root. And the bottom one I multiply by square root of 2, so this is going to be minus square root of 10 over 2. Then to rationalize, after I rationalize these, they're considered done. But now I have to flip them around to get the cosecant, secant, and cotangent. So doesn't matter which ones I do, I still have to rationalize it. So I'm going to do the original numbers. So this is going to be minus the square root of 7 over the square root of 5. Secant is going to be square root of 7 over square root of 2. Cotangent is going to be minus the square root of 2 over the square root of 5. So for cosecant, multiplied square root of 5 over square root of 5. So this is going to be minus root 35 over 5. This one, secant, I do square root of 2, square root of 2. So this is going to be square root of 14 over 4.
Square root of 2 times square root of 2 is 2, not 4.
4. Cotangent, multiply both sides by square root of 5. Up and down, so I've got minus the square root of 10 over 5. Let's try a different type of a problem. It would say given sine theta is equal to 1 over 2, find cosine theta and cosecant theta. So for here, knowing that sine is opposite over hypotenuse, when I make my triangle, this is hypotenuse, this is opposite, this is adjacent. Hypotenuse is 2, opposite side is 1, so now I have to find the adjacent side. So I'm going to use a is equal to the square root of c squared minus b squared. So a is going to be 2 squared minus 1 squared. So square root of 4 minus 1, which is the square root of 3. So the adjacent side turns out to be the square root of 3. So this problem only wants me to find cosine and cosecant. Cosine is adjacent over hypotenuse, so it's going to be adjacent root 3 over hypotenuse is 2, and cosecant is the reverse of sine, and sine is opposite over hypotenuse, so this is going to be 2 over 1, which is just 2.